Good afternoon, everyone. Today, we'll be speaking about dispatcher caching and more specifically about using time-to-live-based caching mechanisms. I'm Robert Botha. I'm a senior technical architect working for Adobe Consulting Services.
And I'm Ben Peter. I do the same thing as Robert. So we have the same roles. So let's briefly look at how we usually do things with dispatcher. Right? In traditional setup, dispatcher cache gets invalidated when authors activate content, right? Usually that means when a page is activated, the entire website gets invalidated in dispatcher. For a CDN, you'll traditionally use a time to live. That's how CDNs work. That means when time is up, the CDN will again fetch the resource from origin. So what are the challenges with that? Number one, your cache hit ratio is a function of how often authors activate content. Number two, you invalidate very broadly, like entire websites, or it gets quite complicated. And number three, looking at how this relates to the CDN, this is either unaligned with how the CDN works, or it gets very complex again. Let's look at each of these. So, the fact that authors' activations determine your cache validity means that it's not operations that have control over how much your cache offloads, rather the authors have that control, right? And you don't know beforehand. And also means that the frequency of activations has a direct impact on the load on the published instances. The more people activate, the higher the load on the published instances. About broad or complex invalidation. So you can choose between a low stat files level or even a single stat file, and that means you probably invalidate unnecessarily broadly, or you need to go really complicated route. And when a resource is activated, you need to look at what's referencing that resource, and you need to invalidate that part in the cache as well, right? Think navigation, content fragments, experience fragments, etc. And about the CDN misalignment, so if we do things like we used to do them, CDN and dispatcher go two different ways, right? AEM is forward invalidating dispatcher, and from a CDN perspective, it's when time is up, the CDN will fetch again, but it's like both going towards the dispatcher in different ways. And if we wanted to align that, again, we'll have to choose a rather complex route, because that would mean that for one thing, we'll need to implement the forward invalidation for the CDN. There is some existing solutions that we can maybe use or no, but it's also additional complexity because you have multiple publishers, right? But only one CDN. And typically that boils down to you having to invalidate the CDN when content reaches each individual publisher, because you never know when the last publish has the content update, so you can only invalidate the CDN once. That's how the traditional approach typically works. And Robert, how would we do that with a TTL-based approach?
Well, thanks, Ben. So as you can see, the traditional approach has quite a few challenges, especially when it comes to more complex sites that have frequent activations, right? So what we do is we look at enabling time-to-live caching in dispatcher. When we do this, effectively, while your page age is less than the time to live, your cache hit ratio approaches 1. You can still use broad and simple invalidation paths, and typically you can align your CDN and your dispatcher time to live settings, so it makes it much simpler from just a deployment perspective to manage the whole process.
Right, so let's look at some dispatcher basics, and this is more just a recap of how dispatcher works. So for one thing, when a page is invalidated in dispatcher, right? An invalidation request comes in from AEM. The stat files from the doc root to the stat files level along the path of the resource are touched. And also the resource as such and any other files with the same base name will be deleted. Other extensions, selectors, suffixes, etc., they all go away, configurable. But that typically means the resource as such that is being activated is evicted, and the rest is down to the stat files. Now, looking at the delivery from cache, the TTL is determined from cache control and expiry headers coming from AEM. So dispatcher respects what origin sends, and that is also how CDNs typically work. If you send a header, the CDN will also respect that. But TTLs can only make resource expiry in dispatcher happen before the stat file would have them expire. It cannot prolong that time. And let's look at why that is. So this is how validity is determined. If the time to live is up, the time to live that was sent from AEM, the page is expired. There's no further checks. And only after that, the other handling comes that everyone already knows. So if the stat file is newer than the cache file, then the grace period is consulted first. Maybe not everyone's aware of the grace period. It defaults to 2 seconds, and its original intention is to prevent overlapping requests. So if that grace period is still on, then the resource is still valid. If it's up, it's expired. And if none of the above applies, if all the checks fall through, the resource is valid and served from cache. So how do we apply that knowledge, Robert?
Right, so the key here is the grace period, right? So we're going to look at some techniques and best practices, and we've done some testing and I'll get to the experimentation towards the end of this presentation, but just quickly. The grace period, this is a setting that's often overlooked, actually. Most people think you enable time to live in dispatcher and you will get the same behavior as you get in a CDN, but this is actually not the case. As Ben alluded to, the stat file is always consulted, and if the stat file is invalid, it doesn't matter what the TTL of that particular resource say, the resource will be refreshed from the publisher. So what do? Well, we set the grace period actually to what we term the default time to live. So it means that pages and resources will always at least be valid for that grace period. You still have control over invalidating pages by activating them directly, because that's how dispatcher works. But you actually get a much closer to CDN behavior for your caching in dispatcher when you set the grace period. You have a couple of settings here that you want to sort of align between your CDN and your dispatcher. I mentioned the grace period. That would essentially be your default time to live in your CDN. We've got ignore URL parameters setting in dispatcher. This roughly equates to the cache key composition in your CDN. Stat files level, the main code in Akamai speak, CP code, sort of. Stat files obviously a bit more, you can fine-tune it, but that's generally what you want to align them to. And then last thing that is not out of box in AM 6.5 at least is a way to actually control these max age values of the cache control header, and that is to use ACS Commons dispatcher cache control header extension. This allows you to, similar to in a CDN, set time to live based on resource types, based on paths, and it really allows you to fine-tune how long your various resources are active. So when you design your time to live policy, you need to consider your different resource types. As I mentioned before, the ACS Commons dispatcher max cache control header control allows you to fine-tune many of these things. Pages, we would typically want to just invalidate based on your time to live. So, and this would be covered by your grace period. If your client can and are happy to, consider removing that star.html from your invalidate section in your dispatcher config, because that is the setting that essentially does what is termed the auto-invalidation. So if HTML is not in that list, it will not consult your stat file when considering a page for invalidation. But then you sometimes have pages that need more special tuning. Think of product pages, think of article pages. You may want to cache longer, you might want to cache shorter. And for that, you may need to do a little more fine tuning. And to Ben, how will we do that?
Yeah, so one mechanism that Robert already mentioned is the ACS AIM Commons dispatcher TTL features, right? You can go by configuration, no coding required, and there's quite the bouquet of options. There's some catches you need to be aware of, like if you use query parameters, if you don't set allow all params, which is not documented, it will not send a TTL. So you'll have to verify it actually works and maybe have a dip in the code of that functionality. But that's one way. You can use Apache to set custom TTLs or send custom expiry headers from your servlets or write your own filters. So there's plenty of options to fine-tune that. Right? If we look at assets, it very much depends on how the agency or the customer work with assets. If assets need to be mutable, that is, an asset of one name changes, then you probably want to go with a medium duration TTL, so that eventually, and not after too long, a changed asset gets reflected. Or you may want to timestamp assets. We did that together in one project. Beware, it's rather complicated, especially if assets are referenced in JSON, JavaScript, whatnot. You need to catch all of those places, and it's not just a rewriter. The easier route is immutable assets. If you can make a contract with the customer or the agency and say, assets are immutable. If you need to change an asset, do it under a new name, reference that new name, then it's that easy, and you can set a TTL of a year or so. Right? So for client libraries, you can use very long TTLs if you use version client libs, which I guess most of you will do. Just one catch to be aware of, the client libs resources proxy, that has a hard-coded TTL of 24 hours. And if anyone shows me a way to rewrite that in Apache, I owe you a beer. I've tried long, I didn't manage. So, but enough of the theory. Well,
yes, I will get to the theory.
Verging to theory and to an actual example of how things may look if we go the TTL route.
Yeah. So, theoretical example. We took these rules and we decided we need to sort of test it. We need to test the hypothesis that time to live will actually increase our effective cache hit ratio, but also lower the load on the publisher instances. So before we did real tests, we sort of plotted down just on a spreadsheet. We plotted a timeline and what happens at which point in time during the life cycle of a request for each part of it. So this theoretical site, we had stat files level set to 4. You can imagine we retail, that would put you at the English node, or language node, right? We had 10 pages and just one image reference across these 10 pages. Scenario 1, we had time to live set to 300 seconds, grace period set to 300 seconds. Scenario 2, time to live set to 300 seconds, grace period disabled. I'm going to quickly touch on the default item there before I go further. So grace period is disabled in AMS's deployments and in the archetype for a 6.5, but it's actually 2 seconds for cloud servers. Don't ask me why, but that is currently how it's set up. So do bear that in mind when you configure these values. And then lastly, scenario 3, that's where we disable time to live, but we actually still use the grace period. And then what did this look like? So as you can see from the graph there, the line is difficult to see in the colors. The line for is the default, is the baseline, I want to call it. And so when there are activations, essentially your cache hit ratio drops from 100% down to almost nothing. And this is expected because every time you activate a page, everything, because the stat file is level 3 or 4, everything on that site has to be rendered again, apart from the images. What's interesting is if we only set time to live, you can see it's the orange bar there, but we do not set the grace period. So I mentioned earlier the grace period is an important setting that we tend to forget about. We see no real improvement. And the reason for that is exactly as we say, the grace period is consulted before the stat files. But if you do not have it set or use the defaults of disable or 2 seconds, essentially you deplete your cache. And then and the other two examples, the blue and yellow, is where we had either both settings set or just grace period. And what's interesting is that by just setting grace period, we actually get a pretty good hit on our cache hit ratio. So this was the theory that we plotted down on a spreadsheet. But we wanted to see what does this actually look like when we run some performance tests on a real site. So this is not, we didn't use a sample site, we used a real site with many pages. For the purpose of this test, we used 42 pages from the site. We had random activations happening every 15 seconds. And we basically ramped up until we got to a request rate of about 250 to 300 requests per minute. And this is what it looks like. So our baseline, as you can see, doesn't look very good. Cache hit ratio is below 50% all the time. It never gets higher. And it never improves. The only time it would improve is if activations stop. The moment you stop activations, of course, your cache hit ratio with the baseline would go to 100%. But that's not how real sites work. And so this was quite an interesting baseline to start with. Our second scenario, or our first scenario then, the first test of the baseline, is where we use both settings. And suddenly you can see here a massive increase in requests per minute. So I just want to quickly go back there. So that we have 250 requests per minute. Bear in mind there's no changes in the parameters of the test apart from changing that time to live setting and adding the grace period of 300. It went up by 50 requests per minute by just us making this small change. Cache hit ratio is hovering around 100% all the time. Those little blips you see there, that's where the grace period is essentially expiring, and the assets and those things also start to get refreshed again from the publisher. Scenario 2, this is now, remember I said earlier, and in the theoretical example, that only setting TTL didn't really show any improvements, and this sort of proves it. So by setting only TTL of 300 in the settings, suddenly we see again a drop in our cache hit ratio to 50. And again, our requests per minute, it never gets over 250. So very interesting. But then the last one is where we do not set the TTL, but we use the grace period. So we have this default time to live, essentially. And again, back to 100% cache hit ratio, 300 requests per minute. And when I saw these results, I thought this is really conclusive evidence that when you tune your dispatcher configuration, do not underestimate setting time to live, but also the grace period setting, something that often gets overlooked. What do you say about that?
I say I better turn on my mic again. So, in summary, I think you can say the traditional approach means you invalidate broadly or complex, and enabling TTL simplifies this a lot. It aligns with how CDNs work, and it gives you a cache hit ratio that doesn't dip when you get a lot of activations. It smoothes out the cache hit ratio. And number two, you can use TTLs to expire earlier, but not to prolong. And you need to set a baseline using grace period, or activations will still invalidate your cache immediately upon activation. And lastly, if you want to tweak handling of particular resources, there's plenty of tools to do that.
Thanks.
What are we taking away, Robert?
Well, it's not food. So takeaways, right? So I'm sort of reiterating what Ben said, but basically, time-to-live-based dispatch invalidation can be much simpler to set up than a complex stat file invalidation approach. It can improve your cache hit ratio, and it significantly smooth out that graph. Do test the edge cases, confirm by simulating users and simulating especially activity of authors, because we all know that the publishers on their own will work perfectly fine, especially if they have the dispatches in front of them. But the moment you introduce that author tier, a lot of things change. So it's very, very important you don't just test your site from the front, but also from the back, and make sure that the two work very well together. Thank you for your time, and we're ready for some Q&A.
Thank you, guys. I also brought some questions. So BT wants to know, plans to add the TTL feature to ACS Commons in AEM itself?
Well, we're both consulting, so we can't really say.
I would love to see that. It's certainly something that there's a lot of features in ACS Commons that are quite useful, and it would be nice to be part of the product. But as consulting, we have very little control. It is definitely something that we want the project team to have a look at.
Henry wants to know, when is the hash functionality for client libs planned to be ported into AEM 6.5 on-prem? It still isn't there.
That's why ACS Commons is there, I suppose.
Yeah.
And this is why it's a good question, and this is why we do recommend using that feature of ACS Commons, because it allows you to have super long caching policies on essentially immutable resources such as JavaScript. Yeah.
Then Roy asks, are there any plans to open source the dispatcher module? Often they find quirks and undocumented stuff, not expected behavior, and would be nice to if you could fix it yourself.
Well, we're getting a lot of questions that we
Yeah,
can't
I think
answer,
next time we need to get engineering up here.
It's
a good question. Again, the dispatcher is a proprietary piece of technology that's under Adobe's license. Of course, we cannot commit that anything would happen. What we can say, though, is we have at least open sourced a dispatcher Docker container that anyone here, we've got some references in the deck, you can go and check out and do your testing using it. That would definitely be something worth checking out. If you, the module itself is in a different language. It's not something that we can commit on, but at least do go check out our dispatcher Docker. It's open source.
Trying to answer that question accurately, I guess we can say it would come as a surprise if dispatcher was open sourced.
That's true. Shake wants to know, how do you deal with concurrent identical requests bombarding a publish, for instance? So DDoS. But,
that is sort of what the grace period was originally intended for, right? So that if the stat file is past the date, it's still giving it 2 seconds to prevent concurring requests, and we're sort of extending that. In I don't know that one example that we used was 15 minutes because that was in the particular scenario what the customer agreed to would be okay to wait until pages expire naturally. But 2 seconds should already be enough to prevent that.
I just want to sort of add on to that. Dispatcher's primary role is not to prevent denial of service. For that, you move up your stack into your CDN and your WAF. So it would not be the primary purpose, but as Ben mentioned, the grace period was originally there to protect your publishers.
And there are several more questions. I think you're happy to answer them afterwards in the chat.
Very
Thank
much,
you, guys.
Thank you.
Thank you.
Laptop, Ben.